Okay, cool. So what did you understand from this document?
We went over this last time, right? So like abstract data is like the instructions in a sense, and like data structure is like the specific way to do it.
Okay, that's okay. We can go deep into it as we work on it. You will understand. And what else did you understand from types of ADTs and their characteristics?
At this, we were also learning in class today. These are just these are like types of data and like the functions you can do with them.
Okay, so can you tell me what did you understand from list?
So like a list can have like multiple like duplicates basically, and you can do like inserting elements or deleting elements.
Yeah, those operations like search,
Yeah,
sort,
yeah,
you can do any and
yeah.
validate whether it's full, the list is completely full or not.
Mhm.
So like that. Okay, nice. Now, how can you implement a list in the program? Because list is a abstract data type. But what data structure helps to create list?
Um, what do you mean by that?
Um, say like if I say roti,
Hmm.
roti is abstract data type, but it can be or maybe I would say bread or what you know. So it can be a wheat, white or wheat.
Oh, like types of bread?
I mean, the real roti means it can be prepared using white bread or wheat
Hmm.
based or many ingredients. You know, there are many flavors to create, right? Similarly, list means it is abstract data type.
Oh, like it can have like characters or integers or
Correct.
strings.
Yes, that is one ingredient. The second is set of integers can be stored in which data structure. Usually, if I want to store 10 student roll numbers, where can I store?
Student numbers would be
Yeah, say
in
that
a list, right?
correct. But when you write a C or C++ program, oh, we don't store it in a list. There is nothing called list, right?
In like a structure, is that?
Did your structure, can you be able to store 100 student IDs or 1,000 in a single structure?
No.
Think. Well, you have already used it in your programming for sure.
Would it, would you
Student,
need an array?
student, yes. Array is the data structure to implement a list, ADT.
Okay.
Okay, that is one. And there is another data structure called linked list. Array is kind of fixed size and it has its own limitations with the memory. But linked list is another structure, or maybe in C++, we can use vector to do that. Vector internally uses linked list. So linked list or vector, I would say. Internally, it uses linked list. So that is dynamic, where you can store any number of elements, delete them anytime, because you can create memory, its size dynamically. But array is
Okay.
kind of fixed size. So when you are declaring an array or one time, you will able to set the memory. So both are lists, arrays or linked lists. Okay. So data structures are array or linked lists, but totally ADT is list. They both create all these implementations with small changes. in the implementation. Good. Now there is one more called set ADT. Okay, we'll go through those, but for now, just remember the names of the ADTs. The programming part would be different from the names, but eventually they have to implement all these operations. Same for map or dictionary. Do you know what's the difference between set versus list?
No.
Okay. List here itself is there. Allows duplicates. Okay. Say like grades. Two subjects are having same grades or maybe same marks, 80 marks. Whereas set doesn't allow duplicates.
Okay.
So you can have subject names in a set, but the marks can be in a list.
Okay.
Okay, so, and map or dictionary. It is always mapping one-to-one or one-to-many sometimes. It is exactly student to the course selection. Okay, for each student, they have their own set of courses. Also, they have their own addresses, all that stuff, right? Their details. So that such details we can store in a map. Okay, it is one-to-many, same as our mathematics maps. Okay, one-to-one or one-to-many it can be. We also say that as dictionary. In Python, we say dictionary. Some languages we use map, some use dictionary as a term, but both are same. Okay, so we always need maps, right? So in the next section, we will be discussing about like the applications of this. But right now, I just want to show you like what are the flavors of ADTs. Stack, which we already discussed during the recursion. Stack follows last in, first out. For the function calls or any real world notation, and like library books arrangements, if they are stacked up, we use stack ADT to represent such simulations. Okay. And then the queue, this is most important in the real world applications as well. It is opposite to stack, first in, first out. It follows any waiting list we store in a queue. Anyways, waiting list in the computer, you need to represent like orders, like online orders or food orders or customer applications or student applications. All are going to be stored in a queue, and then that queue gets processed one after another based on the order. There is one more concept called priority queue here. Priority queue means, as I said, right, if you are a Prime member, the orders can be delivered quickly compared to regular customers. So that is called priority queue. So we are going to implement the programs for each of these abstract data types. Okay. Once you write a program that uses data structure, and then the graphs, it's the most important thing in the data structures, or I would say graphs are the heart of data structures subject. Okay. If you are familiar with the above, graphs are very easy. Okay, graphs are also special kind of maps only, but they are like many-to-many mapping. Example, our route maps, Google Maps is the application of graph data, graph abstract data type, and many more. But just remember the names. Same for the trees. Trees are special. I would just remember graph means many-to-many. Tree means one-to-many. For now, just remember like that. Tree is a special kind of graph. Graph means you will have start point and end point but both are single points. And in between, you will have many-to-many mappings. It's like a neural network graph is.
Mm.
When you come to the tree, it will have one start point, but there is no one end point. You will have many endpoints. It is
Oh,
exactly like family tree. First
okay.
generation, they'll have two kids.
Mm.
They'll get married and they'll have, each one is having two more kids. So that the family tree gets increased. And there is no single endpoint, right? Multiple endpoints will be there, but start point can be one. That is the same thing with
Okay.
trees. It is a special kind of graph. Cool. So these are all real life applications. You can go through
Mm.
like using lists. So these are a few set of applications. Like if you are working for Amazon, the shopping list, or maybe for Microsoft Calendar or Outlook Calendar, you may have to-do list or meeting schedules. If you go to Twitter or Insta, those timelines, these are all lists because you can have duplicates there. You can post the same thing multiple times. So these are all, or same way you can have multiple orders with, multiple items can be listed in the same order, multiple quantities, more than one product you can order. So you do save those in list. Whereas again, list can be ordered or unordered. Ordered means
Okay.
based on time or age or multiple parameters, you can order those.
Mm.
Uh, you know, based on the properties of the items, you can do those orders. But when it comes to the unordered list, it's again completely, uh, you know, unordered.
It's different. Yeah.
There is no order. And then there are certain times hybrid scenarios too. But these things you can learn through theory. As we start coding, then we will understand more. Okay. So that's why I would let you to go through this maybe next session about the applications. But today we would like to start with one application for one data structure, at least, or one ADT using one or two data structures. And let's apply that. While we are applying, you will be learning all this. But I just noted down for the theory purpose.
Okay.
To catch up. Suppose in your college you might have learned this, so that you can go through this material.
Okay.
Okay, so let's dive deep more into array data structure today, in the rest of the time. So you can copy paste these programs, they will run. But right now I will share my screen and directly run the code. So usually arrays are by default static. Like once the size is fixed, you can modify.
You can't modify?
Yeah, we can modify.
Okay.
So 10 is here. If I want to increase it to 20, you should go to linked list. Usually
Okay.
there is a concept of vector, but it internally either delete the existing array, creates a new array, copy paste the element. Either it will delete and create a new array, or it internally uses another concept called linked list, which uses dynamic memory allocation, which we have already learned, right? The pointers concept, malloc or realloc functions in C. So that is called dynamic memory allocation. So that way we can create memory whenever we need, and then that memory can be deleted also based on the requirement. So right now let's see the static array, which you already know, but I would like to revise you. The operations are insert. If I want to insert a value, I'll check first whether the array is full or not. If the array is full, I I'll simply return, I don't insert. Otherwise, I'll just increase its current size where it's in technically it's not size, it can be index. So initially index is 0, and whenever we add a new element, it gets increased after assignment, which we already know that. Oh, this is crazy. Don't mind. As you practice, so you copy paste this code, start practicing and play around, you will understand. And let me know if you have any doubts. But unless you don't see, you can learn swimming without jumping into water, right? Anyway, you have to start coding. The more you code, you'll learn and practice.
Yeah.
This is very simple concept. So let's run that. Initially, it is some default value, and then inserting and getting that. If I delete it, okay, give me a second. Insert 10, insert 20 means you should have 10 and 20. And then the get. So let's see. There's something wrong. We should get 10 at first. But instead of 10, it's giving something else. That's crazy. Let's run it through debugger. See here. Something is wrong with this. Okay, I'll put a print statement to see whether it is inserted or not. See, this is always the case. You cannot have debuggers at office when you go to company because they are microservices. It's hard to debug. So you always need to use these print statements to understand what is happening. something to see whether it is really inserting or not. Something else is inserting. Okay, get of 0 is having a problem. No, that's the problem. This is the problem. What I was doing is I put index here. Index means after incrementing, index value is 1, right?
Mm-hmm.
Initially, index was 0.
Yeah.
And then here I am doing 0 plus plus. This is important. So data of index plus plus means 0 plus plus is equal to the value 10. What will happen?
Oh,
What is the meaning of this statement?
it's saying that 1 is equal to 10.
No, it is postfix, right? Postfix means you should perform operation and then increment.
Oh, okay.
So it means data of 0 equal to 10. In our array, 0 will be stored 10. Okay. After that, it will be incremented to 1, which will be incremented. The value index will be incremented to 1. You got it. Now,
Yeah.
when I was getting here, I was trying to send position 0, get 0. 0 means the value is position. 0 will be stored in position.
Mm-hmm.
And it will check. Yes, it is valid position. The reason is position is not a negative value. At the same time, position is not more than index value. Because what is the index value here? 1.
Mm-hmm.
But position is 0. So position is non-negative, also less than 1. So it is still a valid. If it is valid, bring this value. Data of position. So what will be written? What is the position value?
10?
Yeah, value is 10, but what is the what number? 0, right? This we are written. And in this, as you said, 10 is being stored. So it will return you 10. Clear?
Yeah.
Yeah. Now let's run, it should work. Where the problem is. At line 1. Unexpected unqualified ID. Yeah, it is not. Inserted 10 2 times, 10 is displaying. But there is a challenge here. What? So once index is implemented, we are inserting 20, right? But it is still showing 10. Oh, okay. So rather than get 0, we need to what did we insert? This value. Now inserted 10, inserted 20. Okay, that is insert operation.
Mm-hmm.
Now delete operation. You can delete whichever you want to delete. That's the summary. So here I am deleting at 1. Index 1 means 20. Index 0
20.
is 10. Okay, index starts from 0. 0 and 1. So if I want to delete 0, it should delete and give you. Technically, it should delete. It should delete at 0. Yeah, this is correct. If you see what happened, get 0. The first value is what? 10. Now I am
Zero
deleting.
is the position.
Yes, 0th
Oh.
position. So now I'm deleting the 0, 0th
Mhm.
position. After deleting it, now the new value is 20.
New zero value is 20.
20, yeah. That's
Okay.
the main.
Yeah.
Earlier, it was like this. Later, if you print 1, it should be empty. This is the one. Initially, 10 and 20 were the value before deletion. After deletion, 20 is there and the others are invalid because the element has been deleted. So there is invalid index. It's not the real one when you are trying to access this part. You understand?
Yeah.
This is invalid because it is deleted.
Yeah.
If I add one more element, you will understand. So like if I add 22, then you will understand. Initially, we will be having 10 and 20. Later, we are getting 20 and 22 because 10 was deleted.
Okay.
If I want to display all the values of an array, how can I do?
I'm not sure.
Simple, one for loop. Void display all for int I equal to 0, I less than the index I plus plus data of I. That's it.
What does void do?
Void means I'm not returning anything. When I'm calling,
Okay.
I'm directly displaying. I'm not returning anything back to the caller. So here caller is main.
Okay.
Okay. So now I'm just going to, I'll avoid all these. Or maybe I can comment on this. For timing, I'll remove. See here, I'm just calling but not printing or doing anything. But when you call, it gets displayed there. So in such situations, you will use void. Same way after deletion, I would like to display this.
But what's the difference between not using void and using void?
That's a good question. I'll show you right away here itself. Array display all, it is void, using void. First time, and I have deleted, and second time I'm displaying this. Okay. So just try to display. Doesn't have to fit your space. Do you get it? Initially 10, 20, 22 were inserted. And then we have deleted what? Here we have deleted this one.
The first one.
0th means 10.
Mhm.
And we have 20 and 22 after deletion.
Okay.
Okay. Now, for your question about the void, right? I want to know the size of the array. How many elements are displayed? I want to know the count.
Mhm.
Okay. If I want to know that count, I would like to return the size. Here, size is stored in index. So return index. If you are returning index, here you should put the data type. Index is integer, so you should
Okay.
put integer. So when I'm calling here, I can display this. Also, I can display this.
But if it gives the same output, why do we need to write the return function? Why can't we always just use void?
I'll show you. That's a good question. You need to think like that to get more knowledge. So that's why I'm typing this statement exactly to prove you how different it is. You see here, size before deletion was 3, after deletion is 2.
Mhm.
Hmm?
Yeah.
So now the advantage, we can print everything here, no doubt. We can print, but certain things we should not print. Example, password. I don't want to print anywhere, but I want to store somewhere. Then return would help you.
Okay.
So if I want to send that password or such information from one place to another place, one function to another function, return is helpful. Display, I mean, print does.
Okay. So return is for storing, and then void is like for printing.
No, think return as a wire,
Okay.
electric wire. Return communicates between switch to multiple sources within the room or across the buildings, from transformer to transformer. Why the connection cable wire, sorry, that electrical wires are nothing but return statements. Whereas the transformer or a power consumption source like our household utilities like light, tube light, or fan or anything, these are treated as print statements or storage statements. You can store the battery or mobile battery. So when I switch on, when I connect the mobile battery or laptop to a particular power source, here return statement is between, like a wire between the source and the laptop. But the battery is what storage. That's how it works, the return. So I can store in
Okay.
database or any other file, or I can send it from one technology to another. Say like Zoom. If I want to sign in into Zoom, I'll log in using Google account. So Google function, credentials function will return username and password to Zoom so that Zoom
Okay.
can log in.
Okay.
That's the advantage of return. Okay. But sometimes I don't need to log in. I just need to display. Okay. So in such situations, void is enough.
Okay.
Cool. This is about static arrays, but I would like to cover at least dynamic array, another program. So dynamic array is, we have 2 minutes, but I would like to cover. Dynamic array is doing exactly same operations. I will give it as a program to play with. It is already available in that notes. So you can just play with this program. It is exactly same what we have done. But I used a concept called vector. Vector
Okay.
is a class available in C++, which will flexibly increase and delete the size of elements into it. Array has always a fixed size of 10, which we have previously developed, right? It was fixed 10 or maybe 100 or 20. But when it comes to the vector, you don't need to worry about that overhead. It's always dynamic. You simply focus more on the data. You don't need to care about the size. That's the difference. So vectors are most popular in C++ because of this dynamic feature.
Okay.
Okay. But arrays too, when you know data is fixed, but you need to do operations. But vector is for unknown size operations. In interviews,
Okay.
interview will have both the questions. They'll ask you to do in both vector and array. So you should play. So please work on this. And next session, we will cover circular array is very small concept. And then application here, I also given a very good application with meetings scheduler. You can try to understand this program, array application, how to schedule our Google Calendar meetings. Next session, I will start with this code and then we will discuss about linked list concepts. And also,
Okay. And these are in notes?
yeah, these are all present in the notes. You can copy paste.
Okay.
At the last section is about the programs. Even the explanation is also typed there. You can see
Okay.
each and every logic is explained there, self-explanatory. But you have to practice type just like how I did. Then you will learn more.
Oh.
Okay. Any questions?